Hey JavaScript heroes! Today, we're diving deep into a super powerful optimization technique, debounce. This isn't just a simple method, it's a critical concept for building highly responsive and efficient web applications. It helps you control how often a function runs, preventing performance bottlenecks and a flood of unnecessary operations. You'll find developers using debounce constantly when handling user input and events, making your apps feel snappier and more professional. At its core, a debounce function wraps around another function, delaying its execution. It typically maintains an internal timer ID. When the debounced function is called, it first clears any previously set timer using clearTimeout. Then, it sets a new timer using setTimeout to execute the original function after a specified delay. If the debounced function is called again before this new timer expires, the timer is cleared once more, and a fresh timer is started. This cycle ensures the original function only executes once a period of inactivity, a pause equal to the specified delay, has passed since its last invocation. It's like waiting for someone to stop talking before you respond. You can use this. You'll frequently use debounce when implementing a search bar with auto-suggestions, ensuring the API call only fires after the user pauses typing. It's also invaluable for real-time form validation, triggering validation logic only after a brief pause in user input, or when handling window resize or scroll events to prevent excessive function calls. Now let's break down the code line by line. First, we define debounce as a higher-order function, meaning it takes a function as an argument and returns a new function. It accepts func, the function we want to debounce, and delay, the wait time in milliseconds. Then, inside debounce, we declare timeoutId. This variable will store the ID returned by setTimeout, allowing us to cancel a pending execution. Crucially, it's defined in the outer scope, making it accessible to the return function via closure. Then, this line returns an anonymous function. This is the debounced function that users will call. It uses the rest parameter, args, to capture any number of arguments passed to it, which will later be forwarded to the original func. Then, when the debounced function is invoked, clearTimeout is called with the stored timeout ID. This cancels any previously scheduled execution of func, ensuring that if the function is called rapidly, older timers are discarded. Then, a new timer is set using setTimeout. It calls an arrowfunction after delay milliseconds. This arrowfunction executes the original func, using apply to pass the correct this context and args from the debounced call. The ID of this new timer is saved in timeoutId. Then, here, we define a simple function called logValue. Its purpose is to output a message to the console, demonstrating what would happen if a debounced function eventually gets called. It takes a single value parameter. Then, we create debouncedLog by calling our debounce factory, passing logValue as the function to debounce and 200 milliseconds as the delay. DebouncedLog is now the controlled version of logValue. Then, this first call to debouncedLog would set a timer for first. However, it is quickly followed by other calls, leading its timer to be cleared by subsequent invocations of clearTimeout. Then, the second call clears the timer set by first and sets a new timer for second. Like the first, this timer will also be cancelled before it can execute, due to the final rapid call. Then, the last call to debouncedLog clears the timer for second and sets a final timer for final. Since no more calls follow within the 200 milliseconds delay, this timer will successfully expire and execute logValue. Finally, the output clearly demonstrates the debounce effect. Only the message from the last invocation, final, is logged to the console, and only after a 200 milliseconds pause from that last call. All intermediate calls were effectively ignored. Mastering debounce is a game-changer for building responsive and performant JavaScript applications. It's a fundamental concept for professional developers. Let me know in the comments what other advanced JavaScript concepts you want me to break down next. If this tutorial was helpful, give it a big thumbs up.